Welcome back to Statistics. I want to talk today about the distinction between a population and a sample in statistics. This is actually related to a distinction we've already discussed, the distinction between inferential statistics and descriptive statistics. So, what is a population? A population in statistics is the collection of all individuals you want to study. So, for instance, I might be interested in the approval rating of the president among all U.S. adults. In that case, my population would be all U.S. adults. On the other hand, a sample in statistics refers to the collection of individuals from whom you actually collect data. So I may go out and randomly survey 1,000 U.S. adults and ask them, do they approve of the job the president's doing? In that case, my sample would be the 1,000 adults that I actually survey and get information from. And the relationship between this and inferential statistics is that in making that move from sample data to claims about the population, you are using inferential statistics. So this is very tightly related to what we've already discussed. Let me go ahead and show you a couple of cartoons that sort of illustrate this distinction between populations and samples. So think of the population as just all the points inside this big circle here. They're all the individuals that we're interested in whatever study we're doing. A sample would consist of some subset of those individuals, and that's the group from which we actually collect data. And again, why do we collect data from the sample? We do that so that we can hopefully find something out about the population at large. And that process of moving from sample data to claims about the population at large is the process of statistical inference. So let's take a look at the ebook and see what it has to say about this topic. Again, I'll scroll down to Module 1, Concepts of Statistics, and let's pop open section 1.28a. And so here we're going to understand the distinction and how to make it between population and sample. And as you might imagine, the format is sort of the same as we've seen. First, a little introductory paragraph, and then a discussion of this distinction. And here you'll see much the same information as we just gone over. Again, I'd ask you to read this. And then a couple of steps that you might consider when you're trying to determine what a population is in a given scenario or what the sample would be. I want to look at one of the examples, and again, there are numerous examples in the text, but I want to particularly look at the third one again. This is an example about an experiment to determine what type of surface finish is best for a certain metal part. So let's take a look. An engineer believes that the type of paint and the drying time influence the surface finish on metal. And they give us a link here to the article. To investigate which combination of paint and drying time would give the best finish, the engineer uses two types of paint and three different drying times, 20, 40, and 60 minutes. 3 parts were tested with each combination of paint and drying time. And so what we want to do here is identify the population of interest and the sample. So let's talk about this for a second. Maybe it's best to begin with the population here. This is an engineer trying to determine the best way to finish these metal parts. And so the population is going to be the set of all parts that are produced by whatever the process he winds up choosing. That's going to be a really large population. In fact, the population probably doesn't even exist as of yet because the parts haven't been produced. He's trying to figure out the right way to produce those parts. So the population is, in some sense, a little bit abstract here. But that is ultimately the end goal, right? He wants to produce the best parts possible once the manufacturing process is underway. So the population would be the set of all parts produced by whatever process we wind up with here. Okay, and what's the sample? Well, let's go back again to the statement of the problem and look. We have here in this paragraph a description of a kind of experiment he's going to do. Basically, he's going to try two different kinds of paint, and for each of those types, he's going to try three different drying times, 20, 40, and 60 minutes. And so, and then for each of those scenarios, he's going to test three parts. So you can imagine here that there's paint type number one where you let it dry for 20 minutes, and then there's paint type number one where you let it dry for 40 minutes. Then there's paint type number one where you let it dry for 60 minutes, and then the same thing for paint type number two. And so it becomes helpful to sort of represent this graphically. And let me show you a little slide I have to help us do that. Here we go. Let me let you see this. I've made a chart here that shows the types of paint, two types. I'll just call them type 1 and type 2, and then the drying time that's allowed for each, 20, 40, or 60 minutes. And so in each of those scenarios, type 1 for 20 minutes, you have three parts. Type 1 for 40 minutes, you have three more parts, and so on. And so the experiment really has like six different scenarios, six different treatments. And in each of those treatments, you've got three parts. So there's going to be a total of 6 times 3 or 18 parts in all. And so there's going to be 18 metal parts that are part of the sample here. And if we go back to the ebook and sort of check on the answers that they give, we'll see that that's basically correct. The sample is three parts, each tested with a combination of paint type and drying time, and so there's 18 parts in the sample. So the process of determining a population and the sample is very important in correctly understanding a statistical study and correctly designing a statistical study. And it's not always completely obvious. And so I hope this example has helped you a little bit in thinking your way through a problem of this sort. We do have a homework from Module 1.2a. I believe that's due in a couple of days. And I hope this has helped you with working your way through that. I'd also, of course, recommend reading our text before you do the homework, and you can also have it open as you do the homework. Good luck on that, and we'll be back at you soon with some more basic concepts of statistics. In the meantime, take care.